Hope you're all having an awesome day. So, second lesson of Unit 7. Drew Cool. I'm not sure which student you are. Is it Gabe? Maybe? I don't know. Hope you're having a fabulous day. Either way. So, we are going to be looking at negative and zero. Andrew. Hello, Andrew. Oh, that makes sense, Drew. Andrew. I get it. So, we are going to be doing zero and negative exponents. And again, if you didn't print these notes out, it's totally fine. You can just, follow along on a separate sheet of paper, write down the examples we do together, and all is well. Your homework, as always, will be in Delta Math, and I labeled it 7.2, being that it's lesson 7, or excuse me, Unit 7, lesson 2. So, how do we figure out why is 2 to the 0 power what it is? So, if we think about this, let's start with what 2 to the 4th power is. 2 to the 4th power, really means I have 1 and then 4 2's. And if we evaluate that, we get 16. And then if we think about what 2 cubed is, it's really like 1 times 2 times 2 times 2. And that's going to give us a value of 8. And so on. If I do 2 squared, it's 1 times 2 times 2 to give us 4. And then 2 to the 1st power is 1 times 2, which is, of course, just 2. So every time we continue this, we see that one of the 2's has been decreased. So if I just think about 2 to the 0 power, that's just 1. There's no, if I decrease by another 2, I took the 2 away, I'm just left with a 1. So this just kind of proves that 2 to the 0 power truly is 1. Which brings us in, if we continue this pattern, what about negative exponents? What if I have 2 to the negative 1? I mean, I can't take a 2 away if there's not a 2 to give, So, if we think about it, if we have 2 to the negative 1, it's really that initial 1, but we're going to divide it by 2. And we're allowed to do that because over here, when we were decreasing by 2 each time, it was really like we were saying, divide by 2. And then divide by 2 again. And then divide by 2 again. And then divide by 2 again. So it would only make sense if I want to keep this pattern continuing on that, that if I did 1 divided by 2, well, I would get half. And then if I divided by 2 again, I would get a fourth. So let's think about what 2 to the negative 3rd would be. Well, I'm going to divide by 2 again. So I'm really going to have 2 times 2 times 2 on the bottom. And that's going to be an 1/8. And if you don't believe me, check with your calculator. 1/2 divided by 2 is a fourth. 1/4 divided by 2 is an 1/8. And so on. So if we go to make a prediction here, 2 to the negative 4th, I'm going to have 4 of these suckers on the bottom, which is going to be 1 over 16, and that really is as if we had divided by 2 again. So that's kind of cool. So I really like that pattern there. So, not sure. You might have seen that in 8th grade. Not sure. I just think it's kind of cool. So, that brings us to some laws here. So, it's really, if we looked at it, 2 to the regular 4th, 2 to the positive 4th was 16. But then 2 to the negative 4th was just 1 over 16. So you're still almost evaluating it the same. You just got to bring it down. Bring it to the bottom. So that helps us with the rule. So 0 exponents. B to the 0 equals 1. Such that B is not going to be equal to 0. There's a lot less people. Yes, there is a lot less people, Andrew. I know. It's okay, though. You guys don't have to watch these live. It's just nice for me because then I can, say, hey, So 0 exponents, any number raised to 0 power is 1. It could be a million raised to 0 power. It's still going to be 1 because we could continue that pattern we did above. And then the really important one here, which may be new, or maybe not, I don't know. Negative exponents, when you have something raised to the negative power, it's 1 over that power. So you bring it, I'll use a different color, darker. So you really just bring whatever has the negative exponent down to the denominator. So that is an important rule. So definitely write that sucker down. I know, Andrew. Ethan normally joins us, but the last couple streams, I don't know where he's been. You have to shoot him an email. He did like the picture of our new corgi puppy in Team, so I know he's out there. All right, so exercise 2 says which of the following is not equivalent? So we have our negative exponent, so that means it's going to be 1 over 5, but now when you move it down, that exponent becomes positive. So 1 over 5 squared is equivalent, so that can't be it. 5 squared is 25, so we really have 1 over 25. So number 3 can't be it as well, because that's true. So we got to think. Which of the following is not equivalent? If we did 1/25th, that decimal is 0.02. Very good, Andrew. It is choice 2. 2 is not equivalent. Very good. Awesome. And if I'm going too fast, just let me know. I'll slow down and scroll up, whatever you want. Exercise 3. I'll zoom out and then I'll zoom back in. If f of x is 3x to the negative squared plus 2x to the 0, then which of the following is the value of f of 2? So let's think about this. I'm just going to rewrite this a little bit bigger. So there's a couple ways we could do this. We could just plug it into our calculator. Too easy. So let's do it by hand. Though you know I'm a fan of the calculator, and it is always a good resource to use to check. So let's see. We have 3 times 2 to the negative 2 plus 2 times 2 to the 0. Now, it's important with exponents, like that negative 2, for example, is only with the 2. That 3 is just 3 times 2 to the negative 2. Similarly, it says plus 2 times 2 to the 0. 2 to the 0 is the only piece that has that exponent. The numbers before it are not attached to that exponent. So, if I was going to rewrite this, let me get rid of some of this stuff down here. 1 second. There we go. There's the chubby marker. Give me some space. All right. So, if I was to rewrite this, that marker is still a little too chubby. All right. We really have 3 over 2. Oh, not negative anymore. 2 squared. So when we move it down, our exponent is positive. And then plus 2 times 2 to the 0 is 1. Let's see if your prediction is right, Andrew. So we have 3 over 4 plus 2. And you said 2 3/4. You are absolutely correct. Choice 1 for the win. Very good. Very good. So let us scooch down. So exponent laws that you've already learned, but you know, it's always good to review them, is we have, when you have the same base, you add the exponents. So same base, we add the exponents. And the shortcut, when you have a power to a power, last lesson we were just rewriting it out. Like if it was 3x, the quantity to the 7th, we were writing it out 7 times. Well, that's like a lot of work, right? And I don't want to do that. So here's a little shortcut. You're really, oops, my highlighter decided to disappear. There we go. We're really just multiplying our exponents together. So we kept the base, but now these two are being multiplied. So it's a nice little shortcut for us there. So an example of that, just to give you one, would be like, I don't know, if I had 4x cubed and that whole quantity is squared, or actually let me give you an easier example first. Let's just say I have x squared all raised to the 3rd power. Instead of writing x squared, x squared, x squared, it's really just x to the 2 times 3, which is x to the 6th. The one where we got to be careful with this rule, and the reason I like you guys to expand it out, is if I was to give you an example like 4x squared to the third. If I did an example like that, we got to be more careful because it's bundled in those parentheses, that's really like saying 4x squared, 4x squared, 4x squared. So how many 4's are there? Well, there's 3 of them. So we got to think that this exponent, there's really like a little 1 there. We don't normally write 4 to the first power. We just write 4. But there is technically an exponent there. So when we go to write this, we really have to write 4 to the 1 times 3. Or you could just write 4 cubed and then x to the 2 times 3. So that cubed is going to both of them. Not just one piece, but everything inside the quantity. So this would really be 4 cubed x to the 6th. So make sure you get these 2 examples down because that's one mistake I see a lot when using that particular shortcut with a power to a power. So just be really careful of that. Okay. So let's do a couple more examples and we'll call it a day. All right. So as we saw last time, when we are dividing and the base is the same, we subtract our exponents. So I got a couple options. I could write them all out and then cross them off, which I don't want to, but I could. Or we can just say x to the 5 minus 3, which is x squared. I wrote the wrong number, didn't I? Good catch, Andrew. I was thinking of the answer before I wrote it down. So yes, 5 minus 2, which is x cubed. Very good. Very good. So let's try another one. We got 3 to the 10th over 3 to the 5th. So we really have 3 to the 10 minus 5, which is just going to be 3 to the 5th. So nothing too earth-shattering there. And then here, we have x to the 8th over x squared. So we're going to do the same process again. Subtract our exponents. We get x to the 6th. Very good. So let me give you one that's a little sneakier, a little harder. What if I gave you, I'm going to call this example D. What if I gave you x to the 6th over x to the 10th? What do you think the answer would be then? Because all my other ones, my exponent on top was bigger than the bottom, but now it's the other way. So what would x be raised to for my answer? Very good, the negative 4th. So we did x to the 6 minus 10, we get x to the negative 4th. Well, in math land, we don't like to write things with negative exponents. So how would I rewrite this so that my exponent would be positive? What would that look like? Thought I was going to hiccup soon. Did I stump you? Or is my stream just super laggy? So we go back to that first page. Where was it? When we had 5 to the negative 2, all we did was switch it to the bottom. Wow. So yes, you are absolutely correct, Andrew. We're going to just move it to the bottom. Where'd I go? Oh, here we are. So your final answer would look like 1 over x to the positive 4th. Very good. Very good. All right. So, and I think that's all I'm going to do for today. Yep. I beat the horse dead. I think those are pretty good. So, I hope this was helpful. You have one assignment. It's marked as needing to be moderated. Yeah, I don't know. So Nightbot doesn't like when you enter the same letters in all at once. So I hit allow, but I'm not sure. But you're right. I see your answer, Andrew. It's 1 over to x, which is 1 over x to the 4th. So you are correct in your answer. So that is all I've got for today. And I hope you have okay time on your homework. If you need help, join me in my office hours. And if you join me in my office hours, then you get to see my adorable puppy. And he's just so cute. Slightly terrorizing because he likes to bite my face. So we're learning the word no. So yeah. So if you have any questions, email me. Join me in my office hours. Maybe if you don't have questions, join me in my office hours because I get kind of bored. Have a good coronacation. Yes, I will try to have a good quarantine coronacation over here. Bye.